This lesson is for FST lesson 2-3 on linear regression and correlation coefficients. Unfortunately, our book is not consistent in their naming of the linear regression line. Sometimes they refer to it as the line of best fit. Sometimes they call it the least squares line. And on the calculator, it's referred to as the regression line. So students just need to be aware of the fact that when those three things are mentioned, they're referring to the same thing. A line of best fit will minimize the sum of the squared residuals, which we learned yesterday in 2.2, and it is also a unique line, meaning there is only one best fit line. The best fit line contains the center of mass, which we'll talk about in just a moment, and the slope and the y-intercept can be computed directly from the coordinates in the data. The center of mass, also called the center of gravity, is found by completing the average of all the x pieces of data and the average of all the y pieces of data. Once you've done the average of both, those two answers become a coordinate. That coordinate will be contained on the line of best fit and is also the center of gravity of that line. You could almost refer to it as like a balance point. So we're going to work with linear models today. Students were given this information yesterday in a handout. They need to be comfortable finding linear models by hand and on the calculator using linear regression. So we're going to do linear models by hand first. When students are doing linear models by hand from a particular set of data, they need to choose two coordinates in order to calculate the slope. It doesn't matter which two the students choose. However, it is recommended that you choose 2 points that are not right next to each other. Typically, I pick the first and the last. So I'm going to go ahead and now calculate the slope between those two coordinates. The way that you calculate, just as a quick refresher, is y2 minus y1 over x2 minus x1. Make sure you subtract before you divide, and you'll find there that you get 10. 10 is the slope, and the letter that we use for that is the letter m. Second step is to use the point slope formula, which is m times x minus x sub 1 equals y minus y sub 1. Students should then substitute in their slope for m and substitute in a coordinate for the y and the x that have the subscripts. It doesn't matter which coordinate students choose to plug into their equation. Typically, I have students either use the first or the last. My only comment about using the first is that typically it's closer to the origin and may affect your line of best fit. So usually we like to pick one that's later on in the data. You do not have to pick one of the two that you've already chosen, but typically that'll be the easiest way to go. Make sure that you fill in the x value and then the y value, and you are allowed to leave that as your final answer. Sometimes it is important to solve for y, to get the y alone, but know that it's not always required. If you decide to solve for y, you will simply work out the distributive property and eliminate the parentheses, and then you'll use algebra to get the y alone. In this case, we'll add 80 to both sides. So we get 10x minus 70 equals y. So either this equation or this equation will suffice as the line of best fit, which we found by hand. On the calculator, you will need to do linear regression by first typing in the data into a list and spreadsheet page. One direction that students need to insert into the list is that they do need to highlight both columns. I apologize if that was not on the list originally. So that's a step in between steps 1 and 2. So let's go to the calculator. Students should type in the data into a list or spreadsheet. To highlight both columns, you use your up arrow to arrow up entirely, and just simply highlight one of the two columns. To highlight two columns at a time, you have to use your shift key. Be aware of the fact that on the gray calculator, the shift key is the button right underneath control. On the black calculator, the shift key is labeled with the word shift, and it's right above the 7. The button does not need to be held down, it just needs to be hit, and then the right or the left arrow used to highlight the column that needs to be highlighted. So in my case, I went to the left. Now both columns are highlighted, and I'm going to go to Menu, Statistics, Stat Calculations, and I'm going to choose Linear Regression. On the CAS calculator or the Inspire calculator, linear regression appears twice. It doesn't matter which one students choose. I usually recommend that students choose the first one because they're the most comfortable with mx plus b. If they happen to choose the bottom one, their answers will not be affected. When you get the pop-up window, it is important that you verify that you chose the one that you intended to. If it doesn't say the one that you want at the top, hit the escape key and try again. The X list was column A, the Y list was column B, so that looks good. So I'm going to use the tab key to go down to OK. Added to my spreadsheet now is the equation that it used and the values for M and for B. So notice that we got the same values as what we had before. The M is 10 and the B is -70. I would like students to scroll down a bit here and see that there are other things that are added. The other piece that we're going to need for a discussion later is the R value. The R value in this case is a 1, and we'll talk about that in just a moment. So let's go back to our equation, back to our notes. So back to our notes, and just a reminder here that on the calculator we got the exact same equation. 10 for the slope, -70 for the B, so we got the exact same line of best fit. The other thing that we're going to do today is talk about correlation coefficient. The correlation coefficient is measured on the calculator as the R value. It measures the strength of the linear relationship between two variables. I want to be real clear here that this is not the sum of the squared residuals, which we calculated yesterday. The sum of the squared residuals is a comparison between two models, and it helps you determine which of the two models is the better model. The correlation coefficient gives you an indication of whether or not the data is forming a linear relationship. Is the data forming a straight line or not? So you're trying to decide if a linear relationship is the best way to describe the data. The picture that's given here with all the different graphs is simply taken out of the textbook from page 98. So if students want to refer to that, that is another option. The R value will always be given to them on the calculator when you use linear regression. The values will always be between -1 and 1. The sign of the R value, meaning whether or not it's positive or negative, tells you which way the line is sloping. If you have a negative R value, that indicates that the line is sloping downwards. If you have a positive R value, that indicates that the line is sloping upwards or has a positive slope. If you're close to 1 or -1, all that means is that the dots are forming a perfectly straight line. It's perfectly linear. If the dots aren't quite as lined up, then it'll be an R value that's a little bit less, like a 0.9 or a 0.8. This particular graph here shows that it's at about -0.5. The negative again means that it's sloping downwards. The 0.5 means that it's still linear, but the dots are not lining up as perfectly as it did on these other two situations. So a 0.5 is going to be a fairly weak relationship in terms of it being linear. Similarly, if you're working with a positive 0.5 for your R value, that indicates a fairly weak relationship, but it still indicates that it's linear. Since it's positive, that means it's sloping upwards. As you maneuver your R value closer and closer to 1, the dots start to line up a little bit more perfectly until you reach 1. 1 meaning a perfectly straight line. There is a possibility of getting an R value of 0, which means it doesn't have a linear relationship at all. That might mean that there is simply no pattern to the dots whatsoever. They're completely scattered. Or it might mean that the pattern that is there is something other than linear. Maybe it's a parabola, for instance. A parabola would not be best described with a linear relationship, so that would have an R value of 0. That's it for the notes. I do want students to practice the topics that we did today a little bit further by working with the data in question 20 and answering the questions that are listed here. There is an additional question here which students are unable to see, so I'm going to minimize this slightly to make it a little bit easier. So again, this is data from question number 20, but I'd like students to attempt A through E here on their own. Keep in mind here that in part E, X bar, Y bar is supposed to look like this, but I'm unable to type those symbols on this particular program. Remember that this is the center of mass. It's found by doing the average of the X's and the average of the Y's. That new coordinate that's discovered should be on the line of best fit. So students can try these right now by pausing the video, and in just a few moments I'll scroll down for the answers.